Okay. Hello, everyone. Thanks for joining this talk. I hope everyone is sound and safe at home. Today, I'm going to talk about Terraform and how it helps to build infrastructure on GCP. And I'll do a quick demo to create some resources on GCP using Terraform. Quickly about me, I'm an IT consultant with more than 8 years of experience. My expertise is in big data, cloud, particularly in GCP and AWS, and come from the DevOps background. And recently become a GD in cloud and Google Cloud authorized trainer. Also, I write some blogs, which you can find on my blog website, pbhadani.com. The services cloud native technologies provides like big data, cloud, and any tailored trainings or workshop in DevOps or cloud. So let's quickly see through the agenda. In this talk, I'm going to talk about the Terraform, give its introduction, how the life cycle of Terraform looks like, and quick commands to how to set up your own laptop or workstation to run Terraform and interact with Google APIs, and a demo afterwards. So Terraform is an open source tool, open source by HashiCorp. It allows to build, change, and version of infrastructure like we do version or change our Java or Python code. It's allows us to manage the whole infrastructure. Maybe it's on the cloud or let's say GitHub or somewhere in a very efficient way. Terraform.io is the official website for Terraform, and all the latest information and documents are there. I'd recommend always to look at Terraform.io for the latest updates. Let's quickly walk through the what Terraform provides us. So Terraform is a tool which follows the infrastructure as a code principle, which means like we define all the infrastructure in a code template. And then if we want to change it, create it, delete it, we do via code. Everything is done via the code. It also manages the state of the infrastructure in a state file and do all these CRUD operation on it. It can infer the dependencies between the resources. When I say infer the dependencies, which means, for example, my Terraform code is going to create two virtual machines and put a load balancer ahead of, in front of it. Terraform can automatically detect that before joining the two VMs to a load balancer, I need to have the two VMs up, load balancer up, and then make a connection. Or another example could be if I want to create a Google Cloud Storage bucket and then put a object in it, then Terraform can detect, okay, it has to first create the Google Cloud Storage bucket, then create the object within the bucket. When we, after we write a code, we can run a plan which lists us what Terraform is going to do with this code, whether it is going to create few resources or destroy it or update it or a mix of these three operations. So that's it. So it gives us like a nice execution plan. And all the resources we can view in a graphical graph way, like which resources depends on what. So the dependencies can be viewed as a graph. Terraform tries to interact with the APIs, for example, Google APIs or AWS APIs in a parallel so that it can create the resources in parallel as much as it can. Here are a few Terraform concepts which I want you to want to make some familiarity with it. So Terraform provides us as a allows us to interact with the API and handle the authentication. For example, if I want to create a resource on GCP, Terraform GCP provider will handle all the API interaction and the authentication to allow me to run or create any resources on the GCP. Resource is a fundamental concept in Terraform. Resource, which means like an object I want to create or an infrastructure object I want to create on maybe on a cloud or using some provider. For example, a VM instance could be a resource or a GCS bucket could be a resource. If I'm managing a GitHub repository, a repository could be a resource. Then all these resources can be grouped in a way which describes our infrastructure architecture, and that is called as a module. And a module helps to build the infrastructure as a whole and can be reused over and over with by different teams or by different people within the teams. Data source allows to read the object properties which are already there in the cloud. For example, there is a VPC network which is already created by maybe a gcloud command or by some other script or manually, and I want to have that network URL in my Terraform code. So instead of hard coding or running gcloud command to get it, I can use the Terraform data source to read the network properties and get me the URL. So whenever there is change in the network properties, Terraform will automatically get the latest value when I run Terraform Plan. And it's, as I mentioned, it stores all the information about what it is going to create or what it has created in a state file that's called Terraform state file. And there are two types of state file. One is local and another is remote. A local state file lives on your local workstation from where you are running a Terraform. So uh, that's okay when we want to just get started with the Terraform, but it's not a good practice to have a local state file when we are working within the team or in a production environment. Because once you lose the local state file, the resources which you created with the Terraform becomes off and you can't manage them anymore. That's why we have a remote state file, which could live on like cloud storage, like a GCS or S3 or on console, so that whenever we want, whenever I run a Terraform, it can read the state file from a remote backend, get the latest copy, and then understand what the code should do. And in this way, as the storage, as the remote state lives in the remote storage, this can be shared easily with the teams or among different people. The benefit comes, there are a lot of benefits from the Terraform. I'm just going to talk about few. So the Terraform and the Terraform modules allows us to reuse the code over and over, so that that helps us to build the infrastructure in a very quick way. For example, if I have written a Terraform code to create one or two VM instances, and if someone wants to create similar pattern, like he or she can just copy the same code or reuse the same code. And if I package that in a module for a particular infrastructure diagram or infrastructure architecture, another team, if they need the similar architecture, they can just call the module and build the infrastructure very quickly. So initial code base might take some time, but once you have some code base, it can be reused very easily. Also, once the resources are created by Terraform, it can be managed in a very easy manner. For example, if I've created a VM instance using a Terraform with 2 tags, and now I want to add 2 more tags, those can be done easily. If I want to change a subnetwork, those can be done easily with the Terraform. We just need to run few commands, and like Terraform will see those Terraform lifecycle commands. We just need to run those commands, and Terraform is going to take care of all those stuff. Also, as we are going to use like doing a lot of code reuse, and also like we can build the infrastructure quickly and destroy it quickly, which means we can bring the infrastructure on demand. That leads us to save the cost. And also it gives the consistent environment all the time. We are running the same code base. So Terraform lifecycle runs is a 4-stage lifecycle. It's a pretty straightforward. First is initialization. We can do using Terraform Init. What it does is it install all the dependencies like the provider libraries, the plugins, and etc., and make the remote backend connection, etc., and good to go. Once the initialization has been done and we have a code base, we can just run Terraform plan and it will list out the execution plan, what it is going to do. Once we are happy with the plan, we can run Terraform apply, which will make Terraform to start interact with the cloud APIs and create the infrastructure on the cloud. And when we no longer need the infrastructure, we can just run Terraform destroy, and the whole set of infrastructure which is created by the Terraform code in a particular directory will be destroyed. To set up Terraform, it's very easy on the Mac. I just need to do like a pre-install Terraform, and it is going to install the latest Terraform libraries. I have a blog which illustrate like how to install on the Linux. Also, those steps are here in the slides as well. Just need to get the library and put in a system path, and we are good to go. For particular this talk, I'm going to interact with the Google Cloud. So we need to have a G Cloud setup on the workstation. There is also another blog which lists out all the steps in a detail and explains how to install a G Cloud. But these are the 3 common steps to install G Cloud on your workstation. Let's move to a demo where I'll quickly show how to create a resource. In this demo, I'm going to show like how to create a Google Cloud Storage bucket using Terraform and get you familiar with the Terraform code base. The code already lives in the GitHub, so you can. I'll share all these links. So it's on the GitHub under the name GDG Terraform GCP Workshop. I have 4 examples. In this demo, I'm going to go over first and second example to get familiar with the Terraform and its variable. So I have already cloned all these this repository in my local system. So I'm going to go on the 01 basic and main.tf. So in Terraform, within one directory, we can define multiple .tf file, and Terraform will combine all those TF file in one big TF file and draw that execution plan. This part where we say provider, we provide a provider named Google. As in this example, I'm going to interact with the GCP, so I'm providing Google. But if you want to interact with AWS, you provide AWS and the required properties for the provider to make the connection with that provider. For Google, we need to provide like which project I'm going to interact with GCP project and which region I should use as a default. So just need to provide our the valid project name where you have access to it. So in my case, let me get my project ID. So I'm going to just paste my project ID, which is workshop demo something, and I'll just keep the region as Europe West 2. In this example, once the connection is set, I'm telling Terraform to give me a Google storage bucket. This is the resource name I want to put within the code. And this is the bucket name I want to have on the Google. As the GCS bucket should be unique, probably I can't use my GCS bucket because probably it has been taken by someone. So let me just give some name, maybe HashiTalk demo 2020, and just leave location as Europe West 2. Before I run this Terraform code, I'll just quickly run gsutil command to show like what all buckets I already have. So as like if I run a gsutil ls, I can only see one bucket, which is workshop demo something. I don't have any bucket with the name HashiTalk demo 2020. So going through the life cycle, the first step is Terraform Init. Going to run, or let me just do a full screen, Terraform Init. Okay, sorry, I'm not in the correct directory. I just need to be in the directory. Going to do Terraform Init. So we see it started initializing the backend. In this example, I have not defined a remote backend. So it is going to initialize the local backend. Then the providers and plugin. It infers that I'm using Google provider. So it will download the Google provider libraries and it tells which version the Terraform is downloading. And at the end, it will print out the message that Terraform successfully initialized. If there are any errors, it will print out the errors here. Now, the second step is Terraform Plan. So when I run Terraform Plan, it's reading the main.tf and inferring what the code wants to create. As this is a fresh code, I don't have a current state file, or a state file is empty, by which Terraform knows that whatever the resources has been defined in the code base, Terraform has to create those resources. So it can infer all these things. And if the third stage is Terraform apply. Again, when I run a Terraform apply, it is going to produce a plan and tell me whether I want to continue or not. But still, it gives the plan in this stage, but still I suggest people or users of Terraform users to still run Terraform plans and not directly run Terraform apply, because by mistake, if you run yes or something, it is going to do start its job. So when I say yes, it says, okay, it is going to create the bucket, and after a few seconds, it has created the bucket. So let me quickly run the gsutil command and see if I have the bucket. Okay, I can see that bucket now. And if I do ls, I can see this Terraform state file, which is the local state file. If I just do Terraform state file, it store all the properties in the state file. It is not advisable to update the state file manually outside Terraform code base. As I mentioned, it also handles the changes. For example, if I say that I want to create a bucket, I want to just change a bucket name, for example. In Google, there is no way to rename a bucket, so it should destroy and recreate a new bucket. So if I just do Terraform plan again, so it says that, okay, it is going to replace this, and the replacement comes from here. This bit, this name is changed from HashiTalk Demo 2020 to HashiTalk Demo 2021, and which is making a forced replacement because there's no way to just rename the bucket in GCP. So if I just do Terraform apply and just say yes, it will destroy the HashiTalk Demo 2020 bucket and then then create a new bucket with the name HashiTalk Demo 2021. So let me just run gsutil command. And I can see now HashiCorp demo 2021, not 2020. Once I no longer need these infrastructure resources or anything, I can just run Terraform destroy. Sorry, my bad. There was a typo, Terraform destroy. It will again print a plan. What Terraform destroy is going to do, it's saying that it will destroy this bucket and these are the bucket properties. So if I'm happy, if I want to really delete it, I will just say yes. And says, okay, destroy complete. Just to check, I can run again gsutil ls, and okay, I don't see the bucket with the name HashiTalk demo 2021. So this should give a sense that how it's easy to manage the resources. So imagine if you want like a few number of buckets, I can just use like count is equals to, for example, if I need like 2 bucket, I can just say like count is equals to 2, which means it is going to run this block 2 times. And I can just amend the count dot index so that it has the unique name. So if I run Terraform plan now, so we can see it is going to create 2 bucket, HashiTalk demo 2020, HashiTalk demo 2021. For example, if for some cases you need 10 bucket, just need to update this count to 10. And if I run Terraform plan, we can see it is going to create all the buckets from 0 to like 9. So 10 buckets it will create. I'm not going to create, I'm just showing the execution plan. And if I run Terraform apply, it will actually create all these buckets. Now, everywhere we are using all these hard-coded names, so which is okay to get started, but in a real projects, we can't use all these hard-coded values everywhere. So that's why Terraform provides a way to variabilize stuff. And I'll come to the variables, but before jump that, if you see here, I had like a main.tf in a one single file. I had all the codes, and in this example, I'm just splitting the code into three different TF files, just to show that the Terraform is going to merge all these files when I run Terraform plan and go through all the code. So in provider.tf, I'm just putting the provider and I'm passing the project value and the region value as a variable. To define a variable, you could define in any TF files. I have generally put like a variables.tf file. I just say variable and the variable name. It's good to put a description, because if someone else is reading your code base, it's quickly helps to know, okay, what this variable is about. It also helps to generate a nice documentation, the type of the variable. And if I want to put any default value, I can just put it. These value can be, we can override in the Terraform TF words file. To pass all these values, we can either pass by CLI, which is okay if you have only one or two variables, but let's say we have 10 or 15 variables. Passing all these 10, 15 variables from a CLI would be cumbersome. So we can define all these variables in a file with extension called tfvars. So for example, if I pass the project ID, the one I used here, I can just paste here, and when Terraform runs it, wherever I'm doing var.project ID, it is going to fill this value. It will, this will uh, here, and for var.region, I'm not defining anything here, so it will take the default Europe West 2. So let's go back to this example directory. Again, I'll do like Terraform Init, because this is another directory, which means another different Terraform project. It will download all the required plugins and everything. Once it is done, I can just say Terraform Plan. A similar example, it will create a bucket, and we can see the location is taking Europe West 2. The name is taking, I'm saying the name would be my project ID and just append a bucket. So it is inferring that name. Now let's see if I just put a region as, if I want to override the region as, for example, Europe West 1, and now run a Terraform plan, and we should see the difference. And we can see that, okay, it's Europe West 1 now. The location would be Europe West 1. And again, if I just do Terraform apply, it will create the bucket. So it started to create a bucket. If the name already exists, it will say, okay, the bucket already exists, and it will fail. Now if I do gsutil ls, I can see my bucket. And if I don't need this bucket, I can just do Terraform destroy and just say yes. There are a couple of more examples which you can explore in your free time. I'm just covering these two initial example to give a feel like how the Terraform helps us to interact with the cloud providers easily and manage all these resources in a very nice way. So that's all for, I think, the presentation. If there are any questions, I can take the questions now. If you want, if you have some questions later on, you can reach me on different social media platform, LinkedIn, GitHub, or Twitter, or you can follow the blogs. Try to write some blogs around GCP and cloud, so you can follow me there.